Okay, welcome, and today we're going to start talking about volumes of solids and how do we use integration to come up with those volumes, especially when it's not something that we have a formula for or easy to do. Okay, so before we get into that, let's start with some basic ideas of volume that we all pretty much know or are familiar with. So when we talk about volume, we're talking about a three-dimensional numerical value, right? So a numerical value for a three-dimensional object, right? So same thing, that area is a numerical value for a two-dimensional object. We can talk about volume as a numerical value for a three-dimensional object. And so volume, we have many different formulas that we've learned in geometry for finding the volume of a shape or a figure, right? A solid. So for example, we have here a rectangular prism. It is just length times width times height. Or we have the volume of a sphere. So this would be the volume of a sphere, 4/3 pi r cubed. And then this is the volume of a cone. And then this is the formula for the volume of a pyramid. Okay? So even though a lot of these have been derived from geometry, we can get the same results by using integration. Okay? So some definitions first, because cylinder is also a geometric shape that we can find the volume of. Okay, so if we look at a cylinder, right, it's just this value, right? But the way we look at a cylinder, you know, like the typical way that we think of a cylinder is like a soup can, right? Circular base and a height, okay? But that's a narrow view of a cylinder. In mathematics, we look at cylinder more general. So first of all, let's introduce some vocabulary that we're going to need to know and understand. And the first one is a cross-section. So cross-section is the intersection of a plane with a solid. That's it. And the cylinder, in this case, is any solid that can be generated by translating a plane region, along a line that is perpendicular to the region called the axis of the cylinder. Okay, so that's the definition of cylinder that we're going to use. And so in the next couple of videos, I'm going to show you examples of what I mean. And then what we're going to do is show you how we're going to bring integration into that. Because right now, we're going to think about it this way. In slicing, we're going to be slicing pieces of the solid. And what we're going to do is we're basically going to find the volume of each one of those slices by estimating first. And then by adding up all of those estimated volumes, those should add up to the volume of the whole solid. Okay, so that's the idea. Very similar to what we did with area, right? We had the rectangles. Well, now we're going to look at areas of slices by using cross-section and the idea of a cylinder. Okay? And also, again, the way we look at the volume of a cylinder, right, really comes down to this. We're going to find the area of the base, right? So each cross-section is going to have an area. So really what it comes down to is the volume is going to become, we're going to take the area of the base, right, which is the part of what we're going to get with the cross-section, times the height of the solid, okay? And so again, that's what we're getting when we talk about cylinder, right? So cylinder, we have a circular base, right? So the area of the circular base is just pi r squared. And then we just multiply by the height. So in general, this is the formula for volume that we're going to use. And so in the next few examples, we're going to show you other general examples. So you'll see figures, and we're going to show you the slicing and how it works. And then we're going to bring integration into it and show you how we can get the exact value by using definite integrals. And until then, have a great day.